Hey everyone. Okay, so chapter 11, ordinary annuities, both the future value and the present value is what we're going to start calculating. All right, let's find out what an annuity is. Okay, so as you know, especially on the personal side, that many transactions involve a series of payments over time. Think of paying off your student loan or getting a car loan and making payments, equal payments to get that paid off within a certain period of time, or a mortgage, right? Having to pay mortgage payments to pay off your loan. And those payments include both interest and principal. So go towards paying off the amount you borrowed, but also to pay the interest that's owed for you borrowing the money. Then on the other side, there's also, say for example, if you make contributions to an RRSP, a Registered Retirement Savings Plan, it's the same thing. You're making a series of payments over time. And an ordinary annuity indicates that it's the same payment, equal payments over the time period. Okay, so when these payments are equal amounts and occur at a regular interval, that's what makes it an annuity. And two common examples, as I mentioned, was a fixed term loan, which would be a fixed term, right? You have a car loan for 5 years. You have to pay the loan off within 5 years. Or a mortgage for 20 years. You have to pay it off within 20 years. Or a retirement savings plan. You're going to contribute to that savings plan for the next 40 years if you're 20, so till about 60 you're going to pay it off or contribute to it for about 40 years. And then you will actually start taking payments out of it, most likely, that are equal and regular. So say on a bi-weekly basis or a monthly basis, you take $4,000 out of it once you were in retirement. Okay, so here's a great visual. Okay, so they say a picture's worth 1,000 years, or a picture's worth 1,000 words. Can't get my words straight today, I guess. But as you can see here, at time 0, which is the present value, so the present value of this would be 0, and then you make payments towards it. And in the end, you'll have a certain amount. Okay, so the time from the beginning of the first payment interval to the end of the last interval is the term of the annuity. So if you make 25 payments once a month, then the end would be 25 for that month. Oops. Okay. Are payments at the end of the payment interval? So if they're at the end, so for example, you borrow money today, your first payment isn't for a month or 30 days. Okay, so are the payments at the end of the payment interval? So in that case, they would be. So are the payments in compounding intervals equal? So if it's compounded monthly and you're making monthly payments, then that means that the payments in the compounding intervals are equal. So that would make it an ordinary simple annuity. If the payment periods and the compounding intervals are not the same, so say you make payments once a month, but it's only compounded quarterly, then that would make it an ordinary general annuity, a little bit more complicated. So if the payment, again, go back up to the top, of the flow chart are payments at the end of the payment interval? If the answer is no, so that would mean they're at the beginning, are the payment and the compounding intervals equal? Yes, that would make it a simple annuity due. Okay, so instead of an ordinary simple annuity, it would be a simple annuity due, or due at the beginning. And again, if the payments and the compounding intervals are not equal, so again, saying that the payments are monthly, but it's only compounded quarterly, then it's a general annuity due. So again, there's two main divisions. One is, are the payment and compounding intervals equal? If yes, or if no, then that decides whether it is an ordinary simple annuity, an ordinary general annuity, a simple annuity due, or a general annuity due. It all depends on the first division here. Are the payments due at the end of the payment interval or at the beginning? So if they're due at the end, you come over here, and then we know it's either a simple or a general annuity. And if you come over here and the payments are at the beginning, then we know that it's either a simple or general annuity due. Okay. So the future value of an annuity is the sum of the future values where all the payments calculated at the end of the term. Okay, so the future value could be calculated by using the compound interest formulas and dealing with each payment individually in a formula, or what we're going to do is continue to use the financial features of our calculator. Okay. Oops, let me go back one. So again, we've got the question. Rob deposits $200 at the end of each month into a savings account. Okay, so at the end of each month, that means that it is either a simple or an ordinary annuity. Okay, so it's not an annuity due because it's being paid at the end of each month. So it's either a simple or an ordinary annuity. And into a savings account earning 6% compounded monthly. Okay, so the payments and the compounding are the same. So we know it's a simple annuity. So how much will be in the account after 10 years? So this is where we want to figure out what our amounts are. So we know right now that there's nothing in there. So we know that our present value is 0. We know that our payment is $200. We know that our IY is 6 because that is the annual interest rate. And we know that it's compounded and paid monthly. Okay, and we know it's for 10 years. So we know our N is 10 times 12 or 120. So you can use the formula that they've given here if you'd like, or we come over here and use our features from our calculator. Okay, so we know Rob deposited $200 at the end of each month into the savings account. And we know that it's 6% compounded monthly. So we're going to use our 6 IY. Then we need to go in and change the PY and the CY. So we're going to push the second key and click IY so that we can get to the second level. That's when we need to put 12, enter. And then we need to go second, quit, to come back up to the main level. And we know again that Our N is 12, which is the number of times it's being paid and compounded, multiplied by the 10 years. So we know our N is 120. We know our payments are 200, and those are payments that are going out, right? Rob is giving $200, so we need to hit the plus minus key so that we have 200 negative, and then we hit the PMT key, and then we need compute, future value, and that is going to give us an answer of $32,775.87. So please make sure that you can do this calculation using the features on your Texas Instrument. So each payment will earn interest until the end of the term, and then the earlier payments will earn more interest because they create interest, and then the interest collects interest over the period, over the life of the loan. So here's one. Calculate the future value of an ordinary annuity with payments of $600 every 6 months for 16 years. The rate of return will be 3.5% compounded semi-annually for the first 5.5 years and 5% compounded semi-annually for the subsequent 10.5 years. Okay, so there's going to be 2 steps here. Okay, so we need to create 2 different future values. Okay, so when we calculate the future value of each sub-annuity, because it changes, right, at the 5.5 year mark, we actually end up getting a better interest rate. So we need to find out what it is for the first 5.5 and then figure it out what it is for the next 10.5. So we're going to use our calculator to calculate this. Okay. Again, if you'd like to use the formula or confirm that you know how to use it and can get the same answer whether you're using the features on your financial calculator or whether you're using the formula, please feel free. But for my videos and the expectations of the class, it's to use the financial features. Okay, so we're going to complete the first one for the first 5.5 years. So we have 3.5 IY, the interest rate annually. Then we need to go in and change the PY and the CY. So we're going to hit the second and the IY button. Okay, 2, enter, because again, the PY and the CY, the payments per year and the compounding per year, it's every 6 months for both the payments and the compounding. So therefore, it's going to be 2 and enter. Now we need to come back up to the other level. So your second quit, so now we're back on the main level. And we need 11N, because again, it's 5.5 years multiplied by the 2, which is the number of times it's being compounded semi-annually. So that's your 11N. And then our payment is 600, and you need the plus minus button to make it a negative 600 payment to give you an answer of $72,0891 for your future value. Okay, so it's at this point, because we're at the 14.5 minutes point, that I will stop it. So I will leave you in suspense for the second half of this answer. See you in a moment.